Okay, so let me say this. Yesterday we were talking about the law of sines. And I said to you that the law of sines works really well if you have two angles and a side. You don't have to do any funny business. We talked about what the law of sines was, wrote it down on our paper. We used it a couple times. Easy stuff. Remember, your calculator needs to be in degree mode. Yeah. So, here's what I'm going to say. I actually did a little bit more studying to see if I could. I did a little more studying to see if I could make this as easy as possible. So I want to change how the notes are going to be. Because if we learn how to do it the same way every time, it will just work out. Okay? So that's where we're going to go. So we saw yesterday that sometimes you can get no triangle. We just solve it like normal, and then we get something that doesn't work. So what happens if it does work? So this is where we were. We had A equals 22, B is 12, A is 42. And we're going to find the other sides and the angles. Don't worry about the fact that it's one solution right now. So we set this up, we cross-multiplied, and we solved, and we got B equals 21.41, and this is where we stopped yesterday. Now, so this is the spot where I'm going to tell you this is going to be super important. Okay, so I'm going to put an asterisk there. I probably should make it a pink one. We solved an equation for sine inverse. We used sine inverse, and we solved an equation. When we solve an equation for sine, how many answers are there? There are two. Okay, how did we, when we were working in radians, how do we find the second answer? We have pi minus the first one. So if we're working in degrees, it's got to be 180 minus this. So there are two options for B. Okay, so the first B is 21.41 degrees. That's the one that came from our equation. So what's 180 minus that? $158.6. Okay, 158.6. Now, so this is the only part that's going to be weird on this. Okay, you could have to remember that you solved an equation, so it generates two possibilities. Now, let's list out the angles. So angle A is 42. Okay, so two possibilities. And so we got to find angle C. By the way, I know that angle A is 42 because that was given to us in our problem. Okay, so first triangle up here, please find C. What do we know about all the angles in the triangle? Those of you sitting there staring at the board, they add up to 180. Okay, so we've got B and A, and you can figure out what C is. No. No.
Oh, wait, no. 137.
116.
What?
Okay, what do you get for C in that first triangle? 116.6. Yep, 116.6. 59 if you kept the two decimals. Now, look at who just hummed me. They add up to 180, right? So 180 minus 21.4 minus 42 is 116.6. Okay. Now, take a look at the other triangle. Look at these two numbers here. Okay. Look at those. Look at that. What are you going to tell me about C?
Not possible.
It's not possible, right? So this one has only one possible triangle. That's why it's one solution. If you get one where they both work, that's one with two solutions. So as long as you operate it the same way, every time, and you know that you have to create the second answer when you do sine inverse, if there's a second set of solutions, you'll find them. Okay, so let's try, get my book out just a second. Let's try another, we're going to do 2 more examples. And then we'll go on to something a little bit different.
You got the 158 by minusing 185 here, right?
Yes, because that's the equivalent of doing pi minus the first answer, like when we do sine.
I was wondering.
Yep. Okay, so okay, so I think that I would like to talk you through this one more time because half you are having your own conversation instead of listening. Okay, so first thing you have to do is realize that it's angle side side. So you're gonna have to do the weird business with the sine and finding both of its things. If you can't remember that, just realize that when you solve a sine equation, it has 2 answers. Okay, so it doesn't matter. So 12, if I put 12 on the top, what goes on the bottom? Sine 20.5. Okay, so then 31 has to be on the top and sine of b is on the bottom. And I would suggest keeping it sine of b because you're going to be throwing a lot of angles around. You got to know what's going on. Okay, so go ahead and find the decimal for sine b. So get to the point where you're at sine b equals. Okay, can't remember from yesterday, cross multiply. So sine b equals what? 0.905. Okay. If you didn't get that, we got a problem. Okay. Cross multiply here. You got to divide by 12. So I just didn't write that stuff. Okay. So this mess is equal to 0.905. Now, sine of b. How do you get rid of sine? Okay. So sine inverse. Make sure you're in degree mode. Twice it happened to me yesterday where I was like, wait a second. These are not good answers. Okay, 64.8. So b is equal to 64.8. But sine has 2 answers. Okay, so the second answer is 180 minus the first answer. So what's your other option for angle B? Okay, 115.2. I like it. Now, your angle A is given to you. It's 20.5 in both triangles. Okay, so now you need to use the fact that the 2 triangles add up to 180, or all that, that triangle angles add up to 180 to figure out the angle C's. Okay, what's angle C for the first one? Yep, 94.7. What's angle C for the second one? 44.3. So notice that we have 2 that work. Okay, so that's that's that. Now, I do want to say this. We're skipping a little bit. When you have your homework, it actually wants you to have a complete triangle. So you would need to go back and find side C for these. Okay, so I'll show you one. I'm not going to do both of them. If I needed to find side C, then I would do, it doesn't matter. I'm going to go A over sine A, sine 20.5. And I'm looking for side C. So what has to go on the bottom if I'm doing the first triangle? Yeah, so it'd have to be sine of 94.7. That would give me the first one, and then I would do the same thing with the second one. So on your homework, when it asks you to find the triangles, it wants complete, full sides, full angles. Okay, so you'll have to go back and find one more side for both of them. But I don't want to take your homework time. Okay, now, get out your paper, your pink paper. So this one is very easy. So there is a formula for finding the area of an oblique triangle. Like we know that base times height divided by 2 is a triangle, but that's if you have the base and you have the perpendicular to the base height. So in the, like up here, we're talking about right here. So it says the area of the triangle is 1/2 base times height. That assumes that the height is perpendicular to the base. Okay, you can't just be like, oh, here's an oblique triangle, and here's the base is 12, and I like this length, it's 15, so I'm gonna use that as the height. It's not the height of the triangle, right? The height is perpendicular to the base. So if we have an oblique triangle, which is non-right triangle, which we talked about yesterday, there is a formula that you can use to find his area. So his area, I gotta see how I wrote it on my paper, because I only wrote it once. Area is equal to 1/2 B times C times the sine of A. Okay, 1/2 B times C times the sine of A. Now, I could rewrite that with all the letters, but it gets a little ridiculous, and I didn't do it on the sheet that I give you for your test. So what I want you to realize about this is you can relabel a triangle whenever you want. Okay, so let's say that I give you this. And I say that this is 24, this is 12, this is 17, and this is 9. Yep, sorry. And we're going to find the area. So the formula for area is 1/2 B times C times sine of A. Even if I have labeled this with other letters, you rename it how you want. Okay, there's no rule that says it has to stay named how I want it, as long as you name it appropriately, like we talked about yesterday. So in this case, I want capital A to be 24, because that's the only angle I have. So I'm going to name this A, capital A. Okay, which means what is the 9? It's lowercase a, which doesn't matter for my formula. I don't need it. Now, this, like some people don't like this, but it's true. Does it matter which one is B or C? Why not? Because they're just going to be multiplied together. They're not different. So the order that I do them, whoop-de-doo, of 12 times 17 is 17 times 12. So it doesn't matter. So to find the area, you literally are going to do 1/2 12 times 17 in whatever order times the sine of the angle. All in your calculator at the same time, and you're done. What do you got? 41.5. Sure. 41.5. And I did not give you units, so it's not anything squared. Just leave it. If there's no units, don't worry about it. Okay, so let's do this one. We're only going to do one other example of this. This is our only other example, and we'll move on to something else. Huh? It's an obtuse triangle. It's very cute. You're so right.
I don't know, Mr. Carpenter's glasses. Especially when he left. Maybe. We were terrible.
Guys, please find an area. Yes, you can. I have a meeting after school, so it'll be a little bit later.
Yeah, Mr. Parker's, do you remember that?
Yeah,
That was wild. Mr. Parker's it was so annoying. And every day he would be like, after all my bachelor, he'd be like, oh, you go get it. And he'd come back and be like, my bachelor's under my chair. Every single day.
Okay, find the area. Please.
Oh my gosh, yeah.
I don't remember much about it. I remember gambling in the back of the bus in Mrs. Collins with Jack.
Those school bachelors were terrible.
I know. Yeah, we did do nothing.
You absolutely rearrange. Rearrange, relabel. Okay.
Oh shoot, I read on the area for this.
Well, one of the silence.
I got very large numbers.
What's a big triangle?
That's a big triangle. Javon, what'd you get for your area?
I didn't do it right.
Uh-huh. Why? Like, tell me, like, what happened? How do you know it's not right?
Because I didn't relabel.
Oh. Yeah, if you don't relabel, you're out of luck here. So if you don't like the relabel idea, then let me show you this. This formula is the angle, whatever the angle is, and the two sides that make up the angle. Doesn't matter. So it's the angle and the two sides that are on either side of it. Okay, so if you're like, hey, I have to relabel because I like to see it, then I'm gonna make this A because I did everything in A. That means the little a would be here, so this is B and this is gonna switch to C. Okay, but it's easiest if you realize that it's one angle and the two sides that make up the angle. No matter what you do, one angle to the two sides that create the angle, the two rays. So it's 1/2 52 times 90 times the sine of 102. I got 2288.9. Okay, and that would be meters squared because it's meters this time. Yeah, because it's area. Okay, now let's see if I can make this. So let's say I have 14. No, that's too small. 40, 72, 24, and 37. Okay, so if I ask you for the area, and this is what I give you. Okay, if this is what I give you, you only have one choice about which angle to use as the angle. What? Yeah, It's 40. Why, Levi? Right, I gotta have the two sides that touch the angle. Okay, that's what you're looking for when you're doing this formula. The angle and the two sides that touch it. Okay, that's probably the easiest way to explain it. What? If you wanted to use the law of sines to find the other one because you really like the angle 72, you can, but why would you do that extra work? So 1/2 of 37 times 24 times the sine of 40. What is that? Say again?
285.4.
Thank you. I heard the 85.4 part, but I didn't hear what was in front. Okay. Questions on that? Grayson? Don't smoke your pencil. Oh, don't smoke your sucker stick either. You look like an idiot. Okay, so we're going to switch gears a little bit, a lot of bit, okay? And we're going to talk about actual applications of this. Okay? So, I need you to pay attention. This I had to go study yesterday.
I'm sorry, what? You had to study?
Yeah.
Oh, what?
So, it's honestly, it's not the math part I had to study. It's the explanation I had to study. Okay? So, we use this stuff in navigation. Okay? I'm not a, yes? Huh? So we're talking about marine navigation, aviation navigation, also talking about compass bearings. So if you were out in the wilderness, like orienteering, that's a thing that people do for fun. If you wanted to be a surveyor, which is where you go out and you like survey the land properties, like you do properties and things, like they use these things all the time. Okay, so this is actual real life potential, not for everybody's job, but for some jobs. So I'm going to explain 2.5 things to you. Okay, so the first thing, there's something called heading. Okay, heading is for ships, planes, any kind of vessel. If you watch any kind of submarine movies, they're always talking about headings. Okay, a heading is measured, by the way, just in case you need to care, this is the extra credit on the first quiz. Okay, a heading is measured from 0 to 360. Okay, so just like we were measuring before, except the weirdness is that it changes where 0 is. 0 is actually at north, which means that south would be what? 180. South is 180. So it goes from 0 at the top and it goes clockwise instead of counterclockwise. So if you watch, my husband likes action movies, so I end up watching all the submarine type movies, and you see the guy underneath and he's like, set the 310, give us a heading of 310 degrees. Okay, so 310 degrees means how far are you off from north? You're traveling over here because there would be 310-ish degrees. That's not a very good example. 310 degrees. Okay, but it starts at 0. Okay, starts at 0 and goes clockwise. So it's different than the math system. Okay? That one's pretty easy to understand because we've been doing 360 degrees. Now, there's something that's related to this. It's also called azimuth, which you don't really need to know for your extra credit. That's a funny word. This one is used for satellite navigation, which is what I found in my research yesterday. Azimuth is about fixed position. So like you could look at a star and you could set its azimuth because it doesn't move. Heading is something that's moving. Azimuth is fixed. So you could say, for example, okay, but like at a certain time of the year, okay, right now, okay. If you had a star like related to north, you had a star over here at west, his azimuth would be 270 degrees. Okay, because north is still 0, and you'll go all the way around to 270 degrees. Do you need to know that? No, you don't. But this is the part I had to study because I was like, what's the difference between those two things? This one is used in navigation and for things that are moving. This one is for things that generally do not move. Okay, so you could say, if you were on the water or you were somewhere and you were like, the azimuth to the tree that's not moving is 270 degrees. Okay, so it's a fixed position of something that's hanging around. Okay, now the last one is called compass bearing. And this is the one that you'd use in surveying or orienteering. Also several other things that I was like, oh, okay, hiking. If you were hiking out in the wilderness with a map, you would be like, okay, this is what we're doing. So the way that you write compass bearing is an acute angle related to north or south. Okay, so compass, and I'll give you some examples in a second because this doesn't make sense until you see it. It's a compass bearing is always an acute angle. Acute means what? Smaller than 90, and it's always related to north or south. Okay, so north is north, south is south, and then there's an acute angle hanging around in there. I'll show you. So here's an example. So for example, if I said, we're gonna draw a picture of this because this is the one that is, your book will say this. So let's say I want to draw an angle that's north 30 degrees west. Okay, so we know we're referencing north, and then we're also turning west, but how far are we turning west? 30 degrees. And so north 30 degrees west would be here. This little angle here would be 30 degrees. Okay, that's what north 30 degrees west means. Now, when we put it back into terms of angles that we've been dealing with, we're talking about this angle, which would be how many degrees? 120, because of the normal 90 and then the 30. This would be 120 degrees. Okay, so let me have you try south 10 degrees west. Just a sketch of it is fine. Okay, so south means you're basing off the south axis down here, and you're turning 10 degrees west, so is that right or left? Left. So you're going, because that's west in that direction, so west 10 degrees. There's your angle that would be south 10 degrees west. Okay, try one more for me, please. Okay, north 45 degrees east is exactly in the middle, right? So north 45 is half of one of those, so it's a 45 degrees in here. 45 degrees the other way too. Okay, so we're gonna do one example. It's a story problem. Ugh. Okay, so you're swimming. Okay. So, because I often swim and use compass bearings when I do it. If you prefer a boat race, you can have a boat race instead of swimming. It'd take you a while for this one, 800 meters. So when you do this, okay, when you do this, starting at point A, and you have no idea where you're going, I would put it in the middle of your paper just to make sure that you have room. Okay, so when you're doing this, this is how you would also take compass bearings out in the woods. Okay, you start at your point and you find north, and then you do north 28 degrees east. Okay, so imagine, you don't have to actually draw it on, but imagine putting your grid on there. So north 28 degrees east would be, here's north, 28 degrees in here. So there's a 28 degrees right in there, which we'll hold on to because we'll need it in a minute. Do you guys follow what I'm saying? There's north 28 degrees east. We're swimming this way toward point B. At point B, we do the same thing. We put our little compass bit on there, and we're doing from point B, we're going north 58 degrees west. Okay, so north 58 degrees is going to be out here. Yeah, me too.
It's a triangle.
It's a triangle. So it does say point C is 800 meters directly north of point A. So that means we're going to come down here. This was 58 degrees this way. Okay, point C lies 800 meters directly north of point A. This is 800. Got to figure out how far did we swim. Okay, now this goes back to some geometry. Okay, let's go over here a second. I'm gonna draw here. Do you guys remember about parallel lines and transversals? Remember seeing that? Some of those angles are equal to each other. Okay, I don't care about the names, but numbers, angles that are in the same position. So here, this guy's called the transversal. Okay, because he cuts across. These are parallel. Angles in the same relative position are the same angle. So this is below and to the right. Below and to the right will have the same angle. Okay. Above and to the left, well, that's the same. Above and to the right will have the same above and to the right. Okay. Also, directly across will be the same as beneath. That's called vertical angles. It's that property that you're using in here. So here's your parallel lines. Here's your transversal. So we know what angle C is. Angle C is up here. I didn't mark him. He's 58 because this is above and to the right of the transversal. This is 58 up here, which means this is 58 in here. Now you have, you can find your other one, and then you have the pair to do the law of sines. Okay, so 20, that was 28 in there, 58. So this guy's 94. Okay. So go ahead and use the law of sines, please, to figure out how far did you swim. Okay, so use the law of sines. So you should have, doesn't matter what order, sine 94 over 800 equals sine of 58 over C, and then sine of 94 over 800 is equal to sine of 28 over A. Right? A, C. Add them all up, what do you get? I got 1,856.6. Okay. Okay, so remember, cross multiply, divide, cross multiply, divide. Okay, so 800 sine 58 divided by sine of 94. So this guy, this C is 425.1. Cross multiply, sine 28 divided by sine 94. This one is 376.5. What are your questions on this? Javon, question? Okay, so cross multiply. So this one, guys, 800 sine 58 is equal to C times sine of 94. Divide by sine of 94. Sine 94. Okay, so that should get you the C, 425.1. Okay.
For C, I had 680.1. We have the same final answer.
So I stole my answer out of the back of the book. What did I do wrong?
I have 800 times sine 58 times 94.
Yeah.
And that's how I got.
What do you got?
I got 680.
Yeah, I got 680.
Okay. What do you get for this one?
I got that.
That one? All right. I typed something in wrong then. Okay. Better?
Yeah.
Okay. All right. So we are gonna do homework tonight on the law of sines. So oh, you guys can't see. I wonder why you weren't complaining. Okay. When it says in 16 and 17, it says solve the triangle. Okay, so 16 and 17 say solve the triangle. It just wants you to find all missing sides and all missing angles. That's what that means. So give me the complete triangle. I truly don't think these will take you super long. Okay, well, there's that, right?
Shouldn't take me as long as it takes me, but I get sidetracked very easily. Like last night, I was doing my chemistry, and I asked Mason to fill up my water bottle. He goes to fill up with the sink water from upstairs. I was like, no, you gotta use the water downstairs. He's like, we have the same water. I heard that. So then we had a whole extensive taste testing contest, and I can tell the difference, and you can't. And then I added like an hour on my own.
See, people like you,
Great.
I can handle it.
No, it is a difference. The upstairs water is like licking a rock.
Okay.
And downstairs is nice.
I feel like that's valid because it goes through different pipes. So it might come from the same, it comes from the same place, but it goes through different pipes.
And I think the water going downstairs is filtered. On the upstairs is not.